Okay, fifth graders, today we're doing Module 2, Lesson 12, and we're going to continue to practice what we know about multiplying decimals, but today we're really going to focus on how estimation is so powerful, because we can really use estimation to help us decide if our product is reasonable. I want to remind you that a product is the answer to a multiplication problem, right? That word also could be a multiple. A multiple is also a product. Do you guys agree? Or an answer, or things like that. Okay, very good. Today's going to feel like a review of what we did yesterday. But I really want us, because it is, but I really want us to emphasize and see how estimation helps you see if your answer is reasonable or not. Okay, so let's first estimate. Go ahead and write 2.31 times 22. Let's estimate. 2.31 is pretty close to what factor? 2. 22 is pretty close to what factor? 20. Okay, so 2 times 20 is? 40. Okay, so let's go ahead and write that first. So if our final answer is in the range of 40, that will help us know that our answer is reasonable. Now, when it says using the standard algorithm, really that's change and undo. Okay, so I want you to write the words change and undo. Now, when the directions say use an area model, you have to use an area model. If the directions say use an area model if it helps you, you just use it if it helps you. It's a suggestion. It's a way to remind you that area models and standard algorithms are really the same thing, but if you do it twice, it helps you check your answer. Make sense? Okay. So let's go ahead and set up our standard algorithm. We have 2.31 times 22. Are we ready to multiply? No. Why not? Why are we not yet ready to multiply? Maham?
Because if you didn't change the 2.31, then 22 would be in the tens place. But if you would change 2.31 by multiplying it by 100, then
right now we have a decimal, so we don't want that. So we're going to temporarily change the problem to get rid of that decimal point. How do we do that? We have to multiply it by 100. Because if I multiply 2.31 times 100, I would get 231, right? Okay, so I'm going to change it. All right. So now my new problem is 231 times 22. It's as if I temporarily erased that decimal. Okay, but I'm going to leave it there. Okay, let's go ahead and multiply. 2 times 1 is 2. 2 times 3 is? 2 times 2 is? 4. Now we are working in the tens, so I'm going to put a placeholder 0. 2 times 1 is? 2 times 3 is? 2 times 2 is? Okay, now I have my partial products. I'm going to add them up. When I add them up, I get 5,082. But because we changed, actually, let me ask you a question. If I forget that I changed the problem because I didn't listen to Miss So and I didn't write this, and I ended up with my answer 5,082, if I go back and check my estimation was 40. Is 5,082 in the range of 40? No. So let's say I completely forgot this change and undo business, but I see, hold on, something goes off in my head saying, error. 5,082 is not close to 40. I actually can just forget about this change and undo because I know that if I put my decimal point, I can think, where could I put my decimal point to make it in the range of 40? If I put my decimal point here, it's still 5,082. If I put it here, is it close to 40? No. If I put it here, is it close to 40? Yes. That's the closest to 40 I could get it, right? So it's good practice to still do change and undo. What would our undo be, by the way? Divide by? 100. And would our decimal point end up there? Yeah. But do you see how your estimation is kind of like another safety net to help you catch if you forget your change and undo? Very good. So this example here shows us why we don't just extend our decimal point and keep it like a place value chart. When we multiply, it's not a place value chart. In fact, let's see. Did we line up our place values? What place value is this? Hundreds. What place value is this? Tens. So are they lined up? No. When we add and subtract, do we have to make sure everything is lined up like a place value chart? Yes. When we multiply or divide, is it? No. Divide, kind of. You could argue that it is because your quotient, it needs to be lined up with your whole, right? But when we multiply, we don't. What we do is it's called right aligned. We make sure that our last numbers are aligned at the right. Does that make sense? Okay, and so because for that reason, it's not a place value chart, and you can't just keep your decimal point in the same place vertically. Oftentimes, you will have place values or decimal points in 2 different places. Okay, good. And of course, and even look here in our answer, our product is in a different place as well. Okay, good. Let's estimate first. 102.64 is pretty close to? 100. Thank you. 495 is pretty close to? Okay, so 100 times 500 is 5 with 4 factors of 10, which is?
50,000.
Yeah, sometimes I need to write it out before I can see how to say it in word form, right? You might feel the same way. Okay, so we know our answer needs to be pretty close to 50,000. Now let's use the standard algorithm. Let's set it up. So again, here's another really good example of when the place values don't line up. What's my rightmost place value in 102.64? It's in the hundreds. If I were to line it up using place value, it would be like this. Do you guys agree? But when we multiply with the standard algorithm, does that look right?
No.
No, right? Because then it's like 5 times 4, which is really crazy. So we just write in standard algorithm, 495. Again, it's that right align, right? Our rightmost numbers, our rightmost digits are lined up. Okay, good questions. So right now it looks like our hundredths is on top of our ones. And if we were adding or subtracting, would this look good for us? No, but we're not. Luckily, we're multiplying. Okay, now, do we need to make a change?
Yeah.
What change do we need to make? Times 100, so that we can make 102.64. It's like when we make the change, we're getting rid of the decimal point, so that now all our, if I were to get rid of this, would the place values then be lined up? Because when I get rid of the decimal point, it's like the 4 is now in the ones place. Make sense? Okay, let's go ahead and multiply. Let's not undo for a second. Let's just think about it. If my estimation says that the answer should be close to 50,000, where would the decimal point need to be for this 5 to be in the 10,000s place? That to be right here, right? Okay, so your estimation helps you check your answer. Now, if I were to undo the problem, undo my change, what would the undo be? Right, to undo the multiplying, which would also put the decimal point right here. So does our estimation and our undo agree about where the decimal point should be?
Yes.
Very good. Don't forget to add your commas after you're done with your decimal points too.